Dear students, this is 10th class mathematics, the chapter number 1, real numbers. In this video, we will learn very short answer questions from various public papers and model papers. This is part 1 video. We will learn some 1 to 20 or 22 questions from this chapter. Here is the question number 1 from the chapter. Question number 1. Example for irrational number is. What is an example for an irrational number? There are some examples for an irrational number: root 2, root 3, root 5, 0.12254 and so on, 1.4142 and so on, pi, e and psi. Here this root 2. Do you know what is the value of root 2? Root 2 is 1.414213 and so on. It is a non-terminating and non-recurring decimal. Root 3 is 1.73205 and so on. It is also non-terminating and non-recurring. And root 5 value 2.23606 and so on. It is also non-terminating and non-recurring. If you observe this decimal number 0.12254 and so on, it is also non-terminating and non-repeating. All these numbers are examples for irrational numbers. Besides pi is an irrational number, and this is e means Euler number, it is 2.718 and so on. It is also non-terminating and non-repeating. And this is called golden ratio, 1.6180 and so on. It is also an irrational number. All these numbers are non-terminating and non-repeating decimals. All such numbers are called irrational numbers. Of course, if you are asked to find, or if you are asked to write an example for an irrational number, it is enough you can write root 2, or it is enough if you write root 3. It is enough. Okay. Now, question number 2. Prime factorize 140. 140 you can write 140 as 2 into 2 into 5 into 7, that is 2 square into 5 into 7. Prime factorization of 140. And what is the prime factorization of 5005? 5005 is 5 into 1001. This is 5 into 7 into 11 into 13. These two bits are appeared in public examination so many times. 5005 is 5 into 7 into 11 into 13. That is prime factorization of 5005 is 5 into 7 into 11 into 13. Next bit. What is the units digit in 6 power 2026? The 6 power 1 units digit is 6. 6 square units digit is 6. 6 power 3 unit digit is also 6. Similarly, 6 power 2026 also ends with 6. Okay, the units digit for 6 power any natural number always end with 6. Good. Now look at question number 5. HCF of 12, 15 and 21. 12, you can write 12 as 2 into 2 into 3. You can write 15 as 3 into 5. And you can write 21 as 3 into 7. Okay, now we have to find the HCF. HCF of two numbers is nothing but the product of the smallest powers of each common prime factors. If you observe all these three prime factorizations, you can find only 3 as a common prime factor. So the HCF of all these three numbers is 3 only. The HCF of 12, 15 and 21 is only 3. Okay, HCF means the product of the smallest powers of each common factors in all the numbers. What is the common factor among all these numbers? You can find only 3 is a common factor. Therefore, HCF is 3. Next, question number 6. Write fundamental theorem of arithmetic. Fundamental theorem of arithmetic. This definition is most important for 1 mark question. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. This is the definition of fundamental theorem. You can write the same definition also as the prime factorization of a natural number is unique except for the order of its factors. Okay, you can write any of the definitions from the textbook. Next, question number 7. Who gave proof to fundamental theorem of arithmetic at first? Who gave proof to fundamental theorem of arithmetic at first? The mathematician is Carl Friedrich Gauss. Carl Friedrich Gauss. Yes, he is known as the Prince of Mathematics. The Prince of Mathematics, Carl Friedrich Gauss, he gave the first correct proof to fundamental theorem of arithmetic. Okay. Next, question number 8. What is the LCM of 2 cube into 3 square, 2 square into 3 cube into 5? We have to find the LCM. Previously we found HCF. Now we have to find LCM. Now in order to find LCM, LCM is nothing but the product of the greatest powers of each prime factor. Each prime factor. You observe these two prime factorizations. Out of the two prime factorizations, what are the different prime factors of bases? 2, 3, and you can also find 5. 2, 3 and 5. You have to list out all prime factor bases 2, 3 and 5. Later you have to pick up the greatest powers. Here for 2 the power is 3. Here for this 2 the power is 2. Among 3 and 2 the greatest power is 3. Therefore write 2 cube. Next 3 square and 3 cube. The greatest power of 3 is 3 cube. And next here there is no 5, but here we have 5 power 1. Therefore into 5. So LCM is equal to 2 cube into 3 cube into 7. 2 cube is 8. 3 cube is 27. And 5. You have to multiply all these 3, will get 1080. So LCM of any two numbers or any two prime factorization numbers is nothing but the product of the greatest powers of each prime factor. Okay, good. Next, question number 9. LCM of p cube q square into r, q power 4 into r cube into s. Here again we have two numbers. We have given the prime factorization of two numbers. Here p, q and r and s are also prime numbers. Okay. Now we have to find LCM. Now in order to find the LCM, again list out all the bases p, q, r and s. List out all the bases p into q into r into s. Next, what is the greatest power of p? 3 here. Therefore p cube. Here q square, here q power 4. The greatest power is q power 4. Here r power 1, here it is r cube. The greatest power is r cube. We have to write cube here. And next into s, s power 1, s. Therefore the LCM of p cube into q square into r and q power 4 into r cube into s is p cube into q power 4 into r cube into s. Please correct this. Question number 10. HCF of p power m into q power n, p power n into q power m, where m is greater than n. Among these two powers, here of course p and q are prime numbers. Here it is p power m into q power n, and the second prime factorization p power n into q power m. Here m is greater than n, means m value is more when compared with n. We have to find HCF. In order to find HCF, we know already that we have to list out all common prime factors first of all. What are the prime factors common? P and Q are common. Therefore, write P and Q. Next, among the powers of m and n, we have to pick up the least value. It is given that m is greater than n, therefore n is the least value or smaller than n. Therefore, the answer is p power n into q power n or p into q whole power n. Is it clear? Good. Now question number 11. LCM of p power m into q power n, p power n into q power m, where m is greater than n is. Now we have to find LCM. LCM means you have to list out all bases of primes. P, Q are prime numbers. Therefore, write P and Q. Next, in finding LCM, we have to find the greatest powers of each prime factors. Greatest powers. Among M and N, which is the greatest number? Yes, M is greater than N, therefore M is the greatest number. Since M is the greatest number, you have to write P power M into Q power M. The answer is PQ whole power M. These are the 11 questions. Now, question number 12. What is the sum of all prime factors of 6? We have to write the sum of all prime factors. Look at the question properly. We have to write the sum of all prime factors of 6. First of all, let us list out the factors of 6. What are the factors of 6? 1, 2, 3 and 6. Among all these 4 factors, what are prime numbers? The primes are, or prime factors are 2 and 3 are prime factors. 1 is not prime, 1 is neither prime nor composite, and 6 is a composite number, therefore leave these 2. So the prime numbers are 2 and 3. And if you find the sum of 2 and 3, what is 2 plus 3? 5. Therefore the answer is, what is the sum of all prime factors of 6? The answer is 5. Next, look at question number 13. Product of least prime and least composite number. What is the least prime number? Yes, 2 is the least prime number. And what is the least composite number? Least composite number is 4. We have to find the product, means multiply 2 and 4. What is 2 into 4? 8. So the answer is 8. Now question number 14. Who is the father of mathematics? The father of mathematics is Archimedes. Archimedes is widely known as the father of mathematics. Next, question number 15. The union of rational and irrational numbers. If we list out all rational numbers and all irrational numbers within a set bracket, then this is called the set of real numbers. And the real numbers is denoted by the letter R. Okay. So, the combination of both rational and irrational numbers is called set of real numbers. Now question number 16. Who is the father of numbers? Pythagoras. Pythagoras is widely known as the father of numbers. Now question number 17. Among the following irrational number is, means it may be a multiple choice question. Look at the options. A 12.132 and option B is pi. Option C 12.121212 and so on, and option D is root 4. If you look at option A 12.132, it is a terminating decimal. Every terminating decimal can be written in the form of P by Q, therefore it is a rational number. And next, this is pi. We know that pi is an irrational number, of course. Now look at option C 12.121212 and so on. It is a non-terminating repeating decimal, therefore it is a rational number. And square root of 4 is equal to plus or minus 2, again it is a rational number. Only except pi, all the remaining 3 options are rational numbers, and of course we know that pi is an irrational number. Here the answer is pi. Now look at question number 18. Among the following rational number is, among the following rational number is. Now look at the options. Option A 12.132 and so on. It is a non-terminating and non-repeating decimal, therefore it is an irrational number. And pi is an irrational number. Root 3 value, it is also a non-terminating and non-repeating decimal, it is an irrational number. But 22/7, it is in the form of P by Q, therefore it is a rational number. Okay, good. Now look at question number 19. Statement 1. HCF of 4, 9 is 1. And statement 2. The LCM of 4, 9 is equal to 36. You verify 4 is equal to 2 square and 9 is equal to 3 square. There is no common factors for 4 and 9 except 1. Such numbers are called co-prime numbers. For any set of co-prime numbers, the HCF is always 1. Therefore, statement 1 is true. And if you look at statement 2, again 4 and 9 are co-prime numbers. Therefore, LCM of two co-prime numbers is always the product of it. product of them. Therefore 4 into 9 is equal to 36. Therefore both the statements are true. Look at the options. Both the statements are true. B, option B, both the statements are false. Option C, statement 1 is true, statement 2 is false. And option D, statement 1 is false and statement 2 is true. We know that both the statements are true. Therefore the option is A. Option A is the correct answer. Now look at question number 20. Statement 1. If LCM of three numbers ABC is equal to L and HCF of the same numbers ABC is equal to H, then the product of numbers A into B into C is equal to L into H. It is given LCM into HCF of three numbers. It is not true when it is for three numbers. If it is for three numbers, then the product of the three numbers is not at all equal to LCM into HCF. But it is of two numbers, it is true. Okay, look at statement 2. If LCM of A comma B are two numbers is L and HCF of the two numbers AB is equal to H, then the product of the numbers A into B is equal to the product of their LCM and HCF. Good. Statement 2 is true, but whereas the statement 1 is false. Now look at the options again. Option A, both the statements are true. Option B, both the statements are false. No. Option C, statement 1 is true and statement 2 is false. It is also not correct. And option D, statement 1 is false and statement 2 is true, as statement 1 is false and statement 2 is true. Therefore, the correct answer for question number 20 is option D. Now look at question number 21. Assertion reason questions. Assertion. HCF of 10 and 21 is equal to 1. Here observe 10 and 21. What are the factors of 10? 1, 2, 5 and 10. And what are the factors of 21? 1, 3, 7 and 21. If you observe the factors of 10 and 21, there are no common factors for 10 and 21 except 1. In such a case, we know that both the numbers are called co-prime numbers. Since they are co-prime numbers, the HCF of any two co-prime numbers is 1. Therefore, assertion is HCF of 10 and 21 is 1 is right. And HCF of the two numbers A comma B is equal to 1 if A, B are co-primes. Yes, if A comma B are co-prime numbers, then since there is no common factor, the HCF of any two co-prime numbers is always 1. Yes, reason is true, assertion is true, and reason is the correct explanation to the assertion, isn't it? Yes. So, if you observe the options, option A, both assertion and reason are true, and reason is correct explanation for assertion. And option B, both assertion and reason are true, and reason is not correct explanation for assertion. And option C, both assertion and reason are true, and option D, both assertion and reason are false. Yes, if you observe this question, assertion is true and reason is also true, and reason is the correct explanation for the assertion. So the answer for question number 21 is option A, isn't it? Very good, students. Now let us learn some more difficult questions from this chapter and some more statement 1, statement 2 questions, and some more assertion reason questions, and some more matching questions from the same chapter, real numbers, in the next video. Thank you. Thank you, one and all.